in this field, and I just want you to guess. Okay? Very similar to what Peirce and Jastrow did. The DB says, I can't see anything, right? I got brain damage. I got the scotoma. There's nothing there. I can't see anything. And Weisskranz said, well, just bear with me here and guess. And it turns out that DB's guesses about visual objects presented in a scotoma were right more often than they were wrong, more often than you'd expect by chance. When he was asked about whether there was an object presented in that portion of the field or not, so he was just guessing about the presence or absence of the stimulus, he was right more often than he was wrong. When he was asked to guess about the location, is it down here or here? Still, both locations in his scotoma, he was right more often than wrong. When he was asked if it was an X or an O, a question about form, he was right more often than he was wrong. If he was asked if it was moving or stable, if he was asked if it was moving fast or moving slowly, if it was a line or a bar, if it was vertical or horizontal or at an angle, he was right more often than wrong. And then finally, when he was asked if it was a large object or a small object, again, he was right more often than wrong, despite the fact that he couldn't see anything. Okay? This is what's known as blind sight. And Weisskranz's classic study of DB, there are other patients like this now. They're relatively rare, but you can find them, established in the neurological domain this idea that there are, it's possible to be influenced by percepts that you're not consciously aware of. What DB is consciously aware of in the lower left-hand portion of his visual field is nothing. But he's obviously being influenced by these stimuli because he can guess about them at levels above chance, just like Peirce and Jastrow's the subjects did. So again, you've got this very nice effect. I'll give you some examples here. This is finger pointing performance. So you ask DB to point his finger where the object is, even though he can't see the object, and he's accurate, relatively accurate. That's pretty good, you know, where the object and the target and his finger, that's very, very good correspondence. Here's perception of orientation. He's pretty good at horizontal versus vertical, not as good at, but still pretty damn good at vertical versus diagonal, and making a distinction between X's and O's that's also well above chance. We're not talking about 60% here, or 55%. We're talking about 90% correct. Here's detection of a grating, and here by grating, we simply mean there's a graded stimulus, set of bars, and are the bars close together or are they relatively far apart? And again, he can't see all. He can't detect very narrow gratings, very dense stimuli. But out here, yeah, he actually does pretty well. Pretty well for a guy who's blind, right? Let's just be blunt about it. There are also, interestingly, cases, at least one case of what's known as deaf hearing. This is a patient IA, who has an analogous lesion not in his primary visual area, but in his primary auditory cortex in the upper portion of the temporal lobe. And again, he can't hear anything, okay? But if you hold up a little message here and says, is there a sound being presented or not? He can do that 100% of the time. He can localize the sound very, very poorly. He's not good about that. He's not good about detecting the language in which the message is being presented or whatever. But at least he can detect the presence or absence of the message. Okay, and that's deaf hearing, roughly analogous to blind sight. I'm going to do two more paradigms really quick. One of these is the neurological syndrome known as prosopagnosia. These are individuals who have damage in a particular part of the brain called the fusiform area, which is thought by many to be specialized for the recognition of faces. Prosopagnosia patients can't distinguish between familiar and unfamiliar faces. They don't recognize people who ought to be familiar to them. They can see the faces, they can describe the faces, but they don't recognize them as familiar. So they don't recognize their wife's face or the president's face or whatever. Here's a nice study of prosopagnosia making use of psychophysiological indices of recognition. So you hook the person up to a little device that measures changes in skin conductance, emotional arousal, to make a long story short. And it turns out that prosopagnosic patients who don't consciously recognize familiar faces, objectively familiar faces, as subjectively familiar, will nevertheless show differential psychophysiological responses to these faces. So there is recognition at some level. It's just not recognition at the level of conscious recognition. One more, hemispatial neglect. Damage here in the temporal parietal junction produces a neglect of space, so that if you ask the person to bisect a line like this, they'll put the hash mark here. It's as if they just don't see that portion of space. That's a problem of conscious perception, if you will. Here is a couple of examples of this. You ask the person to draw a flower, and they leave off the left-hand portion. You ask a person to cross out the angled lines that they see, and they eliminate. They don't see the items in the left-hand portion. That's what visual neglect looks like. Here's a lovely experiment by Marshall and Halligan, two British neurologists, who presented images like this to the subjects. Okay, here's a house, and here's a house, and here's a house, and here's a house. When you present the pair in panel A, you ask the subject, was there any difference between these? He says no, okay, because neglect patients neglect the left-hand portion of space, and they apparently don't attend to this smoke. But then what Marshall and Halligan said was, well, which house would you rather live in? And neglect patients always chose the bottom house, right? So again, there's perception at some level, but it's not perception at the level of conscious awareness. Subliminal perception, masked priming, prosopagnosia, blind sight, visual neglect. These are 5 examples of what we have to call implicit perception, where there is the influence of a stimulus in the current perceptual environment on the person's experience, thought, and action in the absence of conscious awareness of that stimulus. That's implicit perception. That's unconscious perception. Okay? I'll have more to say about this on Monday. Thank you very much. Have a good weekend.